everybody, welcome back to my channel. So today we're going to learn about the fractions, decimals and percentages. All right, so let's start with our first topic for today, which is fractions. Okay, now what is a fraction? Basically, a fraction is a number that is written in the form of a upon b, where a and b are integers. Like it is written in the form of a upon b, right? Okay. Now, fraction is basically a part of a given number. Okay. Fraction is a smaller part, okay, as a smaller section of the whole, right? For example, if there's a circle and it is divided into, let's suppose, 8 parts, and we are only considering one part of a circle, it will be written as the whole parts are 8, right? And we are only considering one part of that whole thing. It's going to be written as 1 upon 8. Now, this is a fraction where 1 is the numerator and 8 is the denominator, okay? So a fraction is written in the form of a upon b, where a is a numerator and b is a denominator. Okay, both the numbers a and b are integers, which means that any of them can be a positive number or a negative number, but on the whole they will be whole numbers. There will be no decimals here. Okay, there will be a solid number, full number. Okay. Now, when we move further, now there are three major types of fractions. Okay. Now, the three major types of fractions are: one is a proper fraction, the next one is a improper fraction, and the third one is a mixed fraction or a mixed number. Right. Now, what is a proper fraction? Okay, I'm going to briefly explain it to you because you have already studied it in your previous classes. So it's going to be a small, I'll just going to recall all those previous concepts in this topic. Okay, now, for what is a proper fraction? Now, in a proper fraction, basically, when you write the fraction in the form of a upon b, where the numerator a is smaller than the denominator, okay, where a is smaller than b, where numerator is smaller than the denominator, it is known as a proper fraction. All right, now where you can see that, for example, 4 upon 7 is a proper fraction because 4 is smaller than 7. 7 is the denominator and 4 is the numerator, so 4 is smaller than 7, so it is a proper fraction. 2 upon 3, in case of 2 upon 3, 2 is a smaller number and 3 is the larger number, or the bigger number, right? The denominator is greater than the numerator, okay? And 1 upon 8, you can see that the numerator is smaller than the denominator. So in this case, all three of them are the proper fractions. Now let's move further. What is an improper fraction? Okay, now improper fraction is a complete opposite for the proper fraction. All right, as the name suggests. Okay, the opposite of proper is improper. Now in improper, what happens is that when we write the fraction a upon b, here the condition applies is that the numerator a is greater than the denominator. Okay, the numerator is larger or greater than the denominator. Okay, now here 8 upon 7. Here you can see that numerator is greater than the denominator. 8 is greater than 7. 15 upon 13. 15 is greater than 13. 7 upon 2. 7 is greater than the denominator. Right? So it is an improper fraction. Now, mixed fraction or mixed number. We can call it otherwise, right? They are called as alternatively, like sometimes we call it as a mixed fraction, sometimes we call it as a mixed number. Now, what is a mixed number? Mixed number is basically a combination of an integer and a fraction, or you can say a whole number and a fraction. It can be written in the form of like this: I and then a fraction. I is basically the integer here, okay, and a upon b is the fraction. Now here you can see that, let's suppose 1 whole 3 upon 4, it is a mixed number, right, or a mixed fraction, where a whole number and fraction both are written together. 7 and a half, 7 and 1 upon 2, it is also known as 7 and a half, right? So 7 whole, 1 upon 2. Here 2 whole, 2 upon 3. So it is a mixed fraction or a mixed number where we have a whole number and a fraction together. Okay? Also, let me tell you one thing. An improper fraction can also be written as a mixed fraction number, and mixed fraction number can also be written as an improper fraction. Let me show you the procedure how both of these can be converted. Alright, so improper fraction can also be written as a mixed number, and a mixed number can also be written as an improper fraction. So how we can write it? Now, if we have an example like we have an improper fraction 17 upon 16, 17 upon 6, and we have to write it as a mixed number. How are we going to do that? Now, in this case, what we're going to do is, you know that the numerator is divided by a denominator. The fraction term, basically, it is written as a numerator is being divided by the denominator. So, we're going to do the same. Okay. So, how it is written as, when we divide 17 by 6. So the numerator is written inside and the denominator is written outside. Okay, so what we're going to do is we're going to divide the numerator or the number 17 by 6. So how many times is 6, 7? So how many times 6 is 17? Since 17 does not come into the table of 6, we're going to write the nearest possible number, which is 6 2 times is 12. Now we have 5 as a remainder, right? So 5 is a remainder. Okay. So how a mixed number is written? Now a mixed number is written like this. We have 17 upon 6, which is also written as 2. It is a whole number, right? The number here 2 will be written as whole, right? We're going to write the remainder as the numerator of the fraction and the denominator as the denominator of the fraction, right? So how this is how it is written as in the form of mixed number. So let me tell you again. So how we're going to write it? Now 5 is the remainder here. Okay, the numerator becomes the dividend, right? The one which is divided, which is being divided. Now here the number, basically this is a quotient, right? How many times, and the denominator becomes the divisor, right? And this is the remainder. Now in the form of fraction, what we're going to do is the quotient becomes the whole number, the remainder becomes the numerator, and the divisor, which is also the denominator, it becomes the denominator here, and it remains the same. The denominator in case of improper fraction remains the same. Okay, because it is the one that is dividing everything. Okay, so it will remain as a divisor. Okay, let me explain it again. Let's suppose we have another number which is let's suppose we have, take another example. We have 18 upon 5. Right, now we have to write it as a mixed number. Now when we divide 18 by 5, what do we have here? 18 is written as the dividend or the one which is being divided, and the denominator becomes the divisor because it is dividing here, so it's also dividing here, right? Now how many times 5 18 is, 18 does not come into the table of 5, so we're going to write the nearest number, which is 5 times 3 is 15, right? And the remainder is 3. Okay, now what we're going to do is the quotient, all right, so the main number, how many times 5 is, that becomes the whole number or the integer, which is 3 whole. Then we write the remainder as the new numerator, and the dividend, sorry, the divider or the denominator comes right as it is, which is 5. So 18 upon 5 can be written as 3 a whole 3 upon 5. Okay. Now, we also know that a mixed number, when improper fraction can be written as a mixed number can also be written as an improper fraction. Now, how are we going to do that? Let's take this improper fraction here. Now, here we can see that 3 whole 3 upon 5. So, how are we going to convert it and write it as an improper fraction? Now, what happens is that we go like this. We go clockwise, right? So, 5 or the denominator gets multiplied with the whole number, and the resultant answer, we will add this a numerator or the remainder to it, right? And this is how it goes. We're going to and the denominator will get multiplied with the whole number, and we will add this numerator to the resulting answer, which goes like this: 5 threes are 15, and 15 plus 3 is 18. We're going to write this amount as the numerator, and the denominator will come as it is, because it is the main thing that is dividing the whole answer, so it will remain the same regardless of the formation of the fraction, whether it is an improper fraction or a mixed number. The denominator remains the same in every case. Okay. Now again, if we have another number, let's suppose we have 7.5 or 7 whole 1 upon 2. What we're going to do, again, the denominator gets multiplied with the whole number. 2 into 7 is 14 plus 1, okay, plus the numerator. So it becomes 15 upon 2, okay. Or you can consider this one as well. 2 whole 5 upon 6, which goes like this. The denominator gets multiplied with the whole number, okay, and then we add the numerator to the answer. 6 into 2 is 12. 12 plus 5 is 17, and the denominator remains as it is. Okay. Now, why it happens like this is because if you see here, right, the 17 is being divided by 6. Now, what is happening here is that the whole number, you can see the quotient here is written here. Now, what is this? Basically, 6 is being multiplied by 2, which gives us 12. Okay. Now, we have the remainder. We have the remainder left. We have to adjust it somewhere. So, the remainder becomes the numerator. All right. So, it was the remaining amount that still has to be added to the fraction. Okay. So, we are just going to add the remainder to it. We are multiplying the divisor and the quotient together, just like this, because what we did here, we are reversing it here. Okay. So when we divided the quotient, we got 12. 6 twos are 12, right? 6 into 2 is 12, and we had the remainder left. We're going to add the remainder to it, so it goes back to what it was in the beginning, 17 upon 6. Okay. So this is how you convert an improper fraction and mixed number, or into like you convert improper fraction to mixed number and mixed number into an improper fraction. Okay. I know it sounds a little bit confusing, but it's not that confusing. Okay. You just go clockwise, and you know that the mass rule goes like multiplication comes first and then comes the addition, right? So what here is happening, multiplication comes first. The first step is multiplication, and after that it is an addition is coming. Okay. First step is multiplication, the second step addition. The Demas rule is division, multiplication, addition, subtraction. So the first thing, multiplication, after that addition. Got it? It's more easier to remember, because sometimes you do get confused whether the addition comes first or the multiplication. So just remember the Demas rule. Going to start clockwise from the bottom, multiply the denominator and the whole number together, and then add the numerator, and the resulting answer will be this, the original numerator, which is 17, and the denominator or the divisor, the thing which is dividing, will remain the same because it is also dividing here eventually, and it is also dividing here. So, okay, so it was dividing here at this instant, and it's also dividing here at this instant, so the denominator remains the same in any case. Okay, so this is what an improper fraction into when converted to mixed number is. Okay. All right, so let's have a look at the example over here. Now we here it says that identify whether each of these is a proper fraction, an improper fraction, or a mixed number. Also, write improper fractions as mixed numbers. Okay. Now, what we have to do here, we have to identify whether each of these given fractions are the proper, improper, or a mixed number. And if we find an improper fraction, we have to convert it into a mixed number, or we have to express it as a mixed number. All right. So, how are we going to do that? First, let's have a look at the example number A, 19 upon 18. Now, uh, think yourself, is it an improper fraction or a proper fraction or a mixed number? I'll give you 2 seconds. Think about it. Now, here you can see that numerator is greater than a denominator. So what does it make? It is an improper fraction, right? Now, since we have an improper fraction, we were asked to convert it into a mixed number. So what we're going to do is we're going to divide 18, we're going to divide 19 by 18. So what do we get? When we divide 19 by 18, we get 18 ones are 18, one remainder. So 19 upon 18 can be expressed as 1 whole 1 upon 18, right? Now, look at the example B. 1 whole 2 upon 3. What is it? Is it an improper fraction or a proper fraction or a mixed number? I'll give you 2 seconds to think about it. Yes, it is a mixed number, right? Now, look at part C. 6 upon 8. A proper fraction, an improper fraction, or a mixed number? Think about it. Yes, it is a proper fraction. How do we know it is a proper fraction? Because here we can see the numerator is smaller than the denominator. So in this case, it is a proper fraction. Okay. Now, look it over here. 33 upon 10. What is it? Yes, it is an improper fraction. Right? Now, what we're going to do is we have to convert the improper fraction into a mixed number. Right? So what we're going to do, we're going to divide 33 by the denominator, which is 10. Now, 10 threes are 30. We have 3 remainder. So we're going to express 33 upon 10 as the quotient, which is 3 whole, remainder 3 upon 10, right? So the denominator of the mixed number is same as the denominator of the improper fraction. Okay. Now let's come to the next topic, which is fraction of a quantity. Now, now we know that a fraction can be a share of a quantity. It can be a part of something, like when we're considering, okay, it's a part of the whole, as I told you earlier, right? So a fraction can be used to describe a share of a quantity. Okay. Now, what the denominator and numerator shows, the denominator shows how many parts of the quantity is divided into, and the numerator shows how many of those parts are required. Let's suppose we have a rectangle, right? And it is divided into how many parts? 1, 2, 3, 4, 5, 6, 7. It is divided into 7 parts, right? Okay. And we are only considering the 3 parts. So we're going to shade 3 parts, 1, 2, and 3. So we're considering the 3 parts. So 3 parts are shaded. All the parts, if we count the parts, the quantity is divided into the whole parts are 7, right? So the denominator has, we will write the total parts the quantity is divided into, or the considered object is divided into, is the number of parts. Okay, so in the denominator we're going to write the number of parts the entire thing is divided into, and in the numerator we're going to write the parts, how many of those parts are considered, like 1, 2, 3. So 3 upon 7, right? Now in case we have 4 parts shaded, this will become 4 upon 7. If we have shaded 6 parts, 1, 2, 3, 4, 5, 6, this will become 6 upon 7, right? Okay. Again, if we have a quantity that is divided into 1, 2, 3, 4, 5, 6, 7, 8, 16 parts. So the entire object, or the entire shape, is divided into how many parts? 16 parts. So in the denominator we write the total number of parts the shape is divided into, or the quantity is divided into. And when we shade, let's suppose we are considering only 7 parts, okay? So, or 7 parts are required. So we're going to write those number as a numerator. So we have shaded part 7. So we're going to write it as a numerator, and the total number of parts in the denominator. Okay. So this is known as 7th part of 16, or 7th upon 16th part of the whole. 7th upon 16th part of the whole. And this can be written as 6 upon 7th part of the whole, right? Now, considering we have a number given, now this was a shape. Now, if we have a number and we are asked to find out 1/8 of this number, so how are we going to find it, right? If we have been given like work out 1/8 of 56. 1/8 of 56 means that 1/8 part of 56. Okay, what does it mean is that it can be written as 1 upon 8. Instead of, we're going to write the multiply sign and then the given number whose whose fraction we have to calculate. 1/8 of 56. Okay, now it basically means it's the same as if we divide 56 into 8 parts and we are only considering one part. So how are we going to calculate it? Okay, so it means that we are dividing 56 by 8. Okay, so how many times 8 is 56? 8 ones are 8 sevens are, right? So the answer is 7. Okay, all right. So let's have a look at an example. Work out 5/8 of 56. Okay, as I mentioned earlier, it means that we're going to calculate the 5 upon 8th part of 56. So how can be written as, we're going to write the fraction considered as it is, and instead of writing off, we're going to replace off with the multiplication sign. 5 upon 8 into 56. Okay, 5 upon 8th part of 56. How are we going to do that? Now, in case of multiplication of fraction, the rule goes by the numerator only multiplies with the numerator and the denominator only multiplies with the denominator. Okay, one rule goes by this. In case of multiplication, in case of a whole number, let's say, we don't write it divided by 1, but every whole number can also be written in the form of fraction where the denominator is always 1. So we can also write 56 upon 1. Okay. Now, in case of multiplication, a numerator only multiplies with the numerator of another fraction, and the denominator only multiplies with the denominator of another fraction. Okay. The denominator does not multiply with the numerator of another fraction. Okay. Now, so in this case, if you see that 5 will get multiplied to 56 and 8 will divide the answer. Now, it can also be written as 5 into 56 upon 8, because 5 and 56 are being multiplied together, and 8. But there's also a possibility, if you see that the denominator is dividing any of the fraction as a whole, we can divide it. Now here we can see that 56 is divisible by 8, right? 8 times 7 is 56, right? Now it divides 56 completely. So in this case, we can divide. 8 ones are 8, 8 sevens are 56. We are left with 5 multiplied by 7, which is 35, right? You can also write it as 5 into 56 upon 8. 56 into 5, 280 divided by 8. Now how many times is 280? We're going to write it as 8 ones are 8, 8, 30, 5 times is 280. So the answer is 35. You can solve it both ways. But if there is a cancellation that being happening in the start, in the beginning, you can do that as well. Okay, if they have a common factor that is reducing it to a simpler form, you can do that. Okay, but always remember that the denominator only divides the numerator, it does not get multiplied to it. Okay. Okay, now let's have a look at an example. Work out 11 upon 12 of 180. Now we're going to write it as 11 upon 12, replacing the of with the multiplying sign. Okay, in one of 190. Whatever you have, the part you have to calculate of a given quantity, whenever you have to find that value of the part that is being considered, you're going to multiply it. Okay, the fraction is being multiplied to the whole in order to find the value of that. Okay, so in this case we have 11 upon 12 into 180. Okay, so what will be the 11th upon 12th part of 180? Okay, that is what we have to work out. In that case, when we have the word of, we have a fraction of this part. It means that we have to multiply, right? 11 upon 12 into 180. Now, here we can see that 12 is in the denominator, which means that it can divide a numerator if the numerator gets divided by it completely, right? Now here you can see that 180 is divisible by 12. 12 ones are 12. 12 15 times is 180. So what are we left with? 11 upon 15. Okay. So when we multiply 15 with 11, we will get 165. Right? So the 11 upon 12th part of 180 is 165. Okay. Let's take another example. Now 2/3 of 96 is basically 2 into 3 of means multiplying of 96. Whenever we have to find the part of a given quantity, we have to multiply it. Now it can also be written as 2 into 96 upon 3 for a simpler method. Now here we can see that 96 is divisible by 3, which means that 3 ones are 32 times is 96. Now 2 into 32. Now the remaining number is 2 into 32. Now 2 when multiplied by 32 gives out 64. Right? So this is how you're going to calculate the fraction, any given fraction of a given quantity. Okay. Now let's have a look at a word problem. Alright, so let's have a look at this word problem. It says that in a school of 858 students, 6 upon 11 are boys. How many boys are there? How many girls are there? Now, um, here we can see that we have a total number of students 858, out of which 6 upon 11 are boys, and we are asked about how many boys are there. So here you can see that we have been given the total number of students, out of which they have been given a fraction which are boys. Okay, so we have to find out the number of boys out of 858 students, and then we have to find the number of girls. So how are we going to do that? Now, we know that the total number of boys is 858, and the fraction of boys, total number of students is 858, and the fraction out of it is 6 upon 11. How many boys are there? 6 upon 11 of 858. So what we're going to do is, we know that the number of students is 858. So for the number of boys, we know that 6 upon 11 of 858 will lead to the number of boys, which is 6 upon 11th part of 858. Okay, so we're going to see if 858 is divisible by 11. So 11 ones are 11. 11, how many times is 858? 78. Now what we are left with, 6 upon 78, right? 6 multiplied by 78. So how many number of boys? 468. Alright, so we have find out the number of boys. 6 upon 11 of 858 leads to 468. Okay, now we are also being asked how many girls are there. So number of girls equals to total number of students. Obviously, out 858 students include both boys and girls. So we have found out the total number of boys, and we do have the total number of students. So we're going to subtract the total number of boys from the total number of students, which is 858 minus 468. Now what we are left with, 390. So the total number of girls in this school are 390. Okay, now the question can also be given to you as, in a school of 858 students, 6 upon 11 are boys. Okay, let's suppose this question is not here, only this question is. In a school of 858 students, 6 upon 11 are boys. How many girls are there? If the question was given to you like this, how are you going to solve it? Now, you know that you have 858 total number of students, and you have the fraction given about the boys. We're going to solve it in a similar way. We have the number of students 858. We have the number of boys. We first going to calculate the number of boys about which we have the information, right? So 6 upon 11 of 858 would give us the number of boys, right? So when we're going to subtract the number of boys from the total number of students, the remainder amount will give us the total number of girls. So in this case, if we were only asked to find the number of girls here while giving us the information of the boys only and the total number, we're going to solve it in the similar way, right? Okay, now let's have a look at another example. A shop offers 1/4 of everything as a special offer, right? So it is giving a discount of 1/4 off, right? The 1/4 of the price will be off as a discount, right? A mobile phone normally costs $168. How much does it cost with the special offer? Right? So we have been given the original cost of the mobile phone, and we have been asked that how much will it cost after applying the special offer, right? Okay, so we do know that the amount of discount being offered, which is 1/4. Okay, so we know that cost of mobile phone is $168. Special offer is we have to calculate the 1/4 part of 168. This is basically the discount which is being applied. Okay, so we have to calculate the discount. So 1 fourth of everything. Now, one fourth of 168, we have to find out how much discount is being offered as a special offer. So we have to find the one fourth of 168. Okay. So here we can see that 168 is being divided by 4. So 4 ones are 4, and 442 times is 168. So we know that the special offer being given is $42. Okay. So this is the discount. So they say, how much does it cost with the special offer? It means that the amount that they are asking us to calculate is the one which is after discount. Okay. So cost of mobile, we have to find out the cost of mobile after the special offer, which means that we have to subtract the amount of special offer from the original cost, right? Discount happens like that. Okay. When we subtract 42 out from the 168, we will get $126. Never forget to put the sign. Okay. The signs or the of the value is very important for securing marks in exams. Never forget to put that. If the value is being asked in dollars, you have to put the dollars. Okay, the currency value should be given. Or if you are supposed to ask the length, so the unit of length must also be written. Okay, never forget it in the answer. So the cost of mobiles after special offer is, we subtracted the special offer that is on the cost from the original one. The leftover amount is the one that we got as a discounted price, right? So this is how you're going to calculate a discount. Okay. So this was it for the fractions. Okay. So I'm going to discuss the percentages and the decimals in the next video. Okay, so this was it for today. I hope you understand it well. And if you didn't understand anything, you can mention it in the comment box down below. Also, I would like to mention one more thing, that if you have problem in any topic related to mathematics, you can mention it in the comment box, and I will definitely make a video on it, and I will help you out. Okay, so meet you in my next video. Till then, take care and bye bye.